In this setup, the car resembles our immune system. The castle is the tumor. The job of this car is to drive towards the castle and hit it down. But as you can see here, it's not that easy because there are walls built all around this castle. Even if the car can drive very fast, it would not be able to reach this castle. So our research, there are two aspects. First is to understand how we can take away those walls so that our immune system can reach the castle or the tumor efficiently. The second part of the research is we now try to find in this castle bricks we can remove, so we make this structure less stable. So when the car can reach the castle, it can hit it down more powerfully.
Cancer has traditionally been treated with chemical drugs, radiation, and surgery. But a groundbreaking new approach, immunotherapy, empowers the body's immune system to attack tumours. This discovery, recognized with the Nobel Prize in 2018, has revolutionized treatment for some cancers.
So now we have medicine that activates our immune system against the cancer cells. We see this is one of the pillars for modern day therapy. However, the challenge is, although many patients benefit from the therapy, many still don't. As high as 80% of patients having the same disease, getting the same medicine, still they don't benefit in the long term.
So this one is sensitive to immunotherapy, and then this one is resistant, and then I'm trying...
But why do some cancer cells persist and survive immunotherapy? This is a question that Yumeng Mao tries to answer. To identify critical building blocks that stabilize tumors, he and his team use the genetic scissors CRISPR-Cas9, a tool capable of precisely editing DNA. Methodically, they deactivate each of the 20,000 genes in a cancer cell, one by one. By analyzing how these genetic modifications influence the cancer cell's survival during immunotherapy, they aim to unlock new pathways to more effective treatments.
So our goal is to find which genes, when you remove them, the wall will disappear and the castle will become less stable for the car to hit down. So this is our lab. In this space, we take the samples from tumor tissue and analyze what's in it, what's in the cancer cells and what are in the immune cells.
This research has already yielded an exciting discovery. In the case of triple-negative breast cancer, an aggressive cancer resistant to treatment with immunotherapy, Yumeng Mao and his team identified a specific gene called NED-D8, which plays a pivotal role in the growth and function of the cancer cell.
When that pathway is lost, the cancer cells become a lot more susceptible to immunotherapy. We even took them into a model where tumor will grow in an experimental animal. What we saw was when that gene was taken out, 80% of the mice were tumor-free after the treatment, as compared to tumors with that gene. This was a very spectacular finding we have made in the laboratory.
The next step is to delve deeper into the role of this gene in actual human tumors. Yumeng Mao and his team are now focused on uncovering its precise function and exploring innovative ways to target it effectively. One approach is to test existing drugs to see if they can be used in combination with immunotherapy, potentially enhancing its effectiveness.
The other approach, which is the harder one, is we start drug discovery projects and then we try to find better and novel compounds that specifically target protein action. But this will be a much more difficult and much longer way to the clinic and to the patients, and with a very high risk of failure.
Yumeng Mao knew from a young age that he wanted to study cancer and dedicate his life to advancing treatments and improving outcomes for patients.
Cancer came into my horizon when I was in junior high school. My grandmother was diagnosed with stomach cancer. I was very close to her. Luckily, she got treatment and she was with us for a very long time. My dream is my work, my team's efforts, our discovery could contribute to recovery of some patients with this disease. And hopefully I'll be involved in that process. So this will make me very, very happy. I'll feel all my efforts, and also people around me, I think the same, that their efforts is paid off.